So here, I say that we need to integrate this by parts. Why? Because we have a simple theta here, and you can treat this, imagine this was x. This would be quite easy to differentiate and eliminate, as it would just be 1, it would just become a constant. If you did it by substitution, well, it just wouldn't work. It would be quite complicated. So let's have a go. So the first thing we're going to do is start labeling terms. So again, this is easy to differentiate. So I'm going to call this u for our uv integration by parts formula. So we could say let u equal theta and v prime be the second term. So now, just a quick note, this one's also easy to integrate. This will give you a tan theta because it's the standard definition. So let's have a go. So u prime will give us 1, and then integrating sec squared will give us a nice tan because the derivative of tan is sec squared. Okay, now, easy stuff. So using the by-parts formula, what do we have? The by-parts tells us that we need to do firstly uv, so these two, minus the integral of these two, so u prime v. Now that means that we're going to have this. So u times v is theta times tan theta, so we'll just jot that in. And don't forget there's limits involved, so it's from pi over 3 to 0, minus the integral of 1 times tan theta, which is just tan theta. And don't forget we've got limits here as well. Now, so far so good. I mean, the first part is easy to solve. We just plug everything in the calculator. If you plug in pi over 3, you should get pi over 3 here, and tan theta should be root 3. So ultimately, this should give us root 3 pi over 3. If you plug in 0, well, this will cross everything out because 0 times anything is 0. So that's done. Now let's go ahead and integrate this term here. So let me just change the color of the pen. So let's see. So if you're not sure how to integrate tan theta, the way I do is I always rewrite it as the integral of sine theta over cos theta, because this is easy to work with. And we can know it's easy because we can just let u be one variable cos and differentiate. We should get some sine term, and then these two will eliminate and it'll become 1 over u, or in this case negative 1 over u. Let's check it out. So we could say let u equal the bottom part, always let it be the bottom part, yeah, cos theta, and then differentiate this one. We should get negative sine theta, and then d theta, and then multiply d theta across. It should be minus sine theta d theta. So yeah, so now all you have to really do is just pretty much observe it here, and now we just say, okay, in this case we can just see that we got sine theta d theta, we have sine theta d theta, and that must equal, just take the negative on the other side, that must equal minus du. Sine theta d theta equals minus du, cos theta is u. So this integral, replacing every term, cos is now 1 over u because u is at the bottom, and sine d theta is negative du, so minus du. And this is pretty much, take the negative outside, this is just 1 over u du. Lovely. And then integrating this will give us the natural log, so it'll be negative ln u. Alright, and u is obviously cos theta, so the final bit will be negative ln cos theta. So let me do it over here. So this would be root 3 pi over 3 minus ln cos theta. And now we just plug in the limits from pi over 3 to 0, only for this bit, yeah? Alright, and then doing that, you should get a final result of all of this should reduce to just simply a log 2. And that's the end of the R1 solution.